so we are moving on with special angles. We're going to do some calculations today involving special angles, not special angles, double angles, and it is going to include special angles as well, especially since we're not allowed to use a calculator. So when they say calculate without using a calculator, we've got to expect that our special angles are going to come into it. All right, now what I forgot to do, I did this last time as well, is I forgot to grab these guys. Let me just grab that and go back here and just put them there so that it's there for us. There we go. All right, so there are our special angles for us. Okay, let's go and jump straight in. All right, so if we have a look at the first question A, all right, what does it look like to you? Does it look like a sine double angle or does it look like a cosine double angle? What does it look like to you?
With sine double angle.
A sine double angle, it certainly does. So what they have given you is here on the right-hand side. So now you can go back and you can do that with it. You can do the reversal of the expansion. So you would end up writing this as the sine of 2 into 15 degrees. So we've doubled 15. That gives us the sine of 30. And we all know that the sine of 30 is 1 over 2. Okay, so nice, simple example to get us started. Let's have a look at B now. All right, what's wrong with B? Can anybody tell me what is it that I need to do to B first before I can proceed? What do I need to do to B first? Sandile?
Take out a negative.
Lovely. So if I took out a negative and I used brackets, what would I write inside my brackets, Sandile?
2 cos squared 22,5 minus 1.
Beautiful. Keep going. I love what you're saying. Go, go, go.
And then it'll become negative outside the bracket, open a bracket, cos 2, open bracket, 22,5.
Mm-hmm. All
And
right, lovely.
then you open negative, open a bracket, cos 45.
Lovely, no problem. There you go. So you don't need brackets anymore, but that's fine. If you do have them, it's not wrong. Keep going. This is great.
And then cos 45 is square root 2 over 2, which means it's going to be negative square root 2 over 2.
Beautiful. Well done. Very good. Lovely. Okay, so there you see. So sometimes we have to factorize and then our special angles come into play. We write them and then we can go and substitute in their value. Very, very good. Anybody feeling brave enough to do question C for us? How would we do question C? Anybody want to do question C?
Okay.
You feeling brave to do that one too, Zandile?
Yes, ma'am.
Okay, what would you write?
So, ma'am, I'd do the FOIL first, which would
Okay.
with the cos squared 15 degrees plus
Okay. Sorry, let me
2
just catch up with you here. All right. So you'd end up with cos squared 15, lovely, plus
2 cos squared sine cos 15 sine 15.
that's it. Sorry, I just made a bit of a mess as I was writing the word cos. Let me just fix that up. Sorry. 2 cos 15 sine 15, indeed. And then at the end here, you'd have
Plus sine squared 15.
excellent. Sandile, I'm loving it. Keep going.
Sine cos squared 15 plus sine squared 15 would equal to 1.
Beautiful.
And then in the middle there we have a sine double angle, which would equal sine 2 open brackets 15.
Lovely. Keep going.
Then 1 plus sine 30, of which sine 30
Excellent.
a half. And then 1 plus a half is 3/2, I think.
Oh, yes, it is. That's very good. Well done. Very, very nice. Good work. Okay, so you understood that perfectly straight away. That was wonderful. I could not have said it better. How's everybody else feeling? Are these easy? Are they making sense? Any questions? Don't forget to take screenshots. Any questions?
No, ma'am.
No. Okay, good. All right. There we go. So we're getting some thumbs ups there. That's nice to see. Okay, so DeAndre, what happened with B? All right, so what Sandile did is she had a look at it and she said it looks like a cosine double angle. All right, so in other words, it looks like this guy in the middle over here, except the 1 is positive and the 2 cos squared A is negative. That's why she took out the negative. Right, so that was the purpose of factorizing out the negative, taking that out and then having brackets. And then what she did is she said that I'm going to double my angle. So 22,5 is going to become 45. It's negative, and now I'm going to sub in my special angles. Okay, the cos of 45 is root 2 over 2. Okay. No problem. All right. There we go. Bongo, we went through that. Okay, so now what I want to do is I want to give you guys an opportunity to practice. Let's just grab this again. Let's practice some of these questions and let's see if we can do these pretty quickly, and then we will try and move on to something else. Okay, if you are confident and you feel as though you can get through these pretty quickly, then I'd say try all 4. If you're not feeling confident, just try the first 2. Okay, and we're going to give you about 8 minutes or whatever the case is, and then we'll start marking. Yes. So Pinga, if you go and have a look at your formula sheet, it looks just like that on your formula sheet. Okay, so they are given to you. Certainly is.
Hello, ma'am.
Hello, Tsagfatso. How are you?
I'm good, and how are you, ma'am?
I'm fine, thank you. Do you have a question?
Yes, ma'am. I just joined. I wanted to ask, what are we
Sure.
doing?
Okay, so we are using our double angle formulae to calculate the value of questions B, D, and B, D, F, and H. We have just done a couple of examples. So the idea is that what you are looking at is an expansion. So you would need to do a reversal of the expansion, right, and write it either as the sine or the cosine of a double angle, and then use special angles to get to the answer.
Oh, okay, I get it. Thank you.
Okay, all right, give that a go. And of course, when you are done, you can pop the word done into Okay, but remember, you're just going to try 2. If you want to try all 4, that's fine. But the minimum is just to do 2. Okay, so Zandile's done, Lorato's done. Mercedes done. Offenses done. Caniso's done. Yanela's done. Trisha's done. Oratile's done. Done all. Well done, Sinenkosi. Done with all. Okay. Awesome. Okay. Anybody want to do B for us? Anybody want to tell me what I should write for B? Let's see who's... Okay, Kamogelo, go for it. Kamogelo. You can unmute and speak.
Hi, ma'am.
Hi. Oh, sorry. Sorry, Kamogelo, I accidentally muted you again. Please unmute.
Hi, ma'am.
Hi, Kamogelo, my apologies.
No problem.
Okay, go for it.
And my book is kind of a mess. Let me just look for it.
Okay.
I am not quite sure about it. My hand was
Okay.
actually up for a question earlier on, and I forgot to take it.
That's fine. No worry. No worry at all. Sinenkosi, do you want to? Sinenkosi, go for it.
Hi, ma'am.
Hi.
So 2 sine 75 cos 75 will be equals to sine 75 plus 75,
Okay.
which will
Or you could,
then be,
did you do that?
yes,
2 times 75. Okay, there we go.
yes, then it's going to be sine 150.
Lovely. And what did you do after that?
Sine 150 is equals to sine 180 minus 30
It is.
equals to sine 30,
Well done.
which is then equals to 1/2.
Beautiful. Okay. Beautifully explained. Well done, Sinenkosi. That was lovely. Okay, very, very good. All right. Anybody want to try D for us? Anybody feeling? Danelle, do you want to try D?
Hi, ma'am. Can you hear me?
Yes, I can hear you. Go for it.
So ma'am, I tried D. So I started off with from 4 sine 105 cos 105 to sine open bracket 4 open bracket 105 degrees close bracket and close bracket.
Okay, sorry, I missed that. So you had 4 open brackets.
I had sine open bracket 4 times 105.
4 times 105.
Yes,
Okay, can I ask why you multiplying it by 4?
I tried, but I didn't know what to do.
That's okay. That's no worry. Okay, so it is a double angle. All right, what you've got to look at here, all right, is that you've got it's hiding, but you've got 2 sine A cos A hiding somewhere inside this monster over here. All right, so the easiest thing for you to do is actually break this 4 down, okay, and write it as 2 times 2. And then you can write sine 105 cos 105 like so. So if you have a look here, Danelle, this is your sine double angle, right? The 2 that's in front, so this 2 over here, it's got to come down to the next line. So what I'm going to do now is I'm going to double 105. So this would give me 2 sine, I'm going to double 105. And that's going to give me 2 sine 210. Okay. Now that I'm here, I can use my reduction formulae. So I can write 210 as 180 plus 30. Does that make sense to you? So 210 is 180 plus 30. Right. So it
Yes.
is, yeah, so that is quadrant 3. So this is going to be negative. So this is going to reduce to negative 2 sine 30 like so. Okay, so I put the negative at the front, or I could write 2 times negative sine 30 if I wanted to, but we generally put the negative at the front. And now I can say negative 2 times the sine of 30. The sine of 30 is a half. So the final answer would be negative 1. Okay.
Yes, thank you, ma'am.
All right, no problem, Danelle. Okay, how are we feeling so far? I see there are a couple of people with hands ups. Amo or Charity, do you want to ask a question?
No, ma'am. Actually, my hand was up to answer a question letter D. Actually.
Oh, okay. Did you do F?
Yes, I did it. I got it
Okay.
right.
All right. So you try F with me. What would you do for F?
With F, I took out the double angle. It gave me cos 2 into 15 degrees. I saw double angle.
That's perfect. Lovely. So that would give you the cos of?
30 degrees.
Excellent. Keep going.
And cos 30 degrees gave me √3/2.
Beautiful. Okay. So F was actually a pretty easy one, even though it was down close to the bottom. Very nice. Well done, Charity. That's absolutely perfect. Sorry, Kamogelo, what did you want to do, F? My apologies. All right. Ethel, your hand is up next. Do you want to do H, Ethel?
No, ma'am, I have a question.
Oh, okay. All right. What's your question?
So number B and D, why do I get a wrong answer when I expand the angle in the bracket and then work with compound angles?
Okay, maybe you've made a mistake somewhere in that, but I think expanding it and working with compound angles really just makes things so much more difficult for you. Also, how would you make 75? So you would have gone 45 plus 30, wouldn't you? It's not wrong to use compound angles. It just makes it so much longer. If you use the double angles, you're going to get your answer in fewer steps. And you're not going to get more marks for a longer answer if you can do it in fewer steps. Okay, so rather stay away from compound angles unless it's absolutely necessary for you to use them, because it is obviously a much longer question. So the potential, because you're writing so much more, there is the potential for you to make a bigger mistake. Okay, that's what I would say. Also, with question D, if you wanted to do compound angles, did you say 60 plus 45? I suppose you could have done that as well. But again, it would have just made it so long. All right, so I would stay away from that because not necessary. Okay, Kamogelo, go for it. You can do H. What did you write?
I said cos squared into 15 minus 2 cos into 15 multiplied by sine into 15 plus sine squared into 15.
Good, well done. Now I'm running out of space on the page. Let me just see if I can navigate over a little bit. I can't. What I'm going to do is I'm going to do. Okay, there we go. I've managed to move all the way over. All right. Okay, plus, let's just go back here. You had sine squared 15. Fabulous. Okay, keep going.
And then from there, I simplified the expression, and then I said cos squared into 15 plus sine, well, they're all in brackets,
Okay.
plus sine squared into 15, closed bracket, and then minus 2 cos into 15 multiplied by sine 15.
There we go. Lovely. All right. And you grouped cos squared 15 and sine squared 15 together because they are equal to? Cos squared.
When I grouped them together, I was simplifying the expression using the Pythagorean identity,
Yes. Okay. The square identity. Absolutely. So what you should have said here is that cos squared 15 plus sine squared 15 was 1. Lovely. Absolutely. Good. And then over here, what did you do with 2 cos 15 sine 15?
The 2 cos, I said 2 cos 15, 2 cos 15 into 15 sine 15.
Yes, was equal to?
Sine into 2 times 15.
There we go.
And then it's going to give us 1 minus sine into 30.
Lovely. Keep going.
And then it's going to be 1 minus half.
Lovely.
And then our answer is half.
Beautiful. Well done. That was very, very well done. Good job. Excellent.
Thank
Okay.
you.
Well done, Kamogelo. All right. How's everybody else doing? Are we good? Thumbs up, thumbs down? Any questions?
Ma'am.
Yes, Sagofatso.
So if I was to skip the step of writing, like if I just write 1 instead of showing it, do I have to indicate that I got 1 from the identity there?
You know what you can do? I'm going to put ticks, all right, where the steps you should write. So you should definitely write that. Okay.
Yes.
You should also definitely write this step over here. Okay, so
Yes.
if you went from cos squared 15, well, from the first line to that fourth line, that would be fine. You should also
Yes.
write this step, and you should write that step over there. Okay, those are the ones that are necessary to show. Absolutely. Okay,
thank
good
you.
question. All right, let's just have a look at everybody in the chat. Okay, it's okay, Cabello, no worries. All right, so most people have got thumbs ups. That's really encouraging to see. All right, so now what I'd like to do is something that is a little bit more difficult with you guys. Okay, so I'm going to actually start with question number 2, and then I'm going to come back to question number 1. Oh, sorry, there were a couple of hands up. Charity, did you want to ask a question? Or Lutando, you've also got a hand up. Are there questions?
Ma'am, can you hear me?
Yes, absolutely.
How are you, ma'am?
I'm fine, and you?
I'm good, ma'am. Can you please go back to the other question that we had, the last one? You see where it's written 2 cos 15 and sine 15. Is
Mhm.
it the same as the double angle true sin cos sin? I mean that right?
Absolutely. Absolutely.
So
So it's
it's not even
exactly,
if it's written like this.
yes. So it doesn't matter that we've written cos 15 before sine 15. Normally we would write sine 15 first, but because we're multiplying, the order doesn't matter. So this over here is absolutely identical to that over there.
Oh, okay. Thank you, ma'am.
Okay. All right. No problem. All right. So let's go back down here. And as I said, I want to do question number 2 before I do question number 1. All right. So starting with question 2, we have sine 36 over sine 12. And we've got cos 36 over cos 12. And again, we can see here our instruction is to evaluate. All right, so without the use of a calculator. When we are subtracting fractions in maths, no matter where we are working, what is the rule for subtracting fractions? What do we always have to have when we subtract fractions?
LCM, like
Exactly.
yes.
Absolutely. So we have to have an LCM or lowest common denominator. What would our lowest common denominator be, Tsegofatso, in this case?
It will be 12 sin and then times cos 36.
Okay, so it would be, so it's our two denominators multiplied together. So it would be sine 12, cos 12.
Yeah, cos 12. Sorry, my bad.
No. Don't say sorry. Not a problem. Okay, so that's our lowest common denominator. Then the idea is what we do to the bottom, we've got to do to the top, right? So exactly the same as if I had 1 over 3 and I needed to subtract, say, 2 over 5, right? I would say my lowest common denominator is 15. It's the product of these two. Okay, so now I'm going to create equivalent fractions. Okay, so I'm going to times that 1 by 5. I've got to times that 1 by 5, and I'd end up with 5. Same thing on this side over here. I'd have to times that by 3. So I must times that by 3, and then over here, I'd end up with that. Now that I've got the same denominator, I can keep the denominator, and I can subtract the numerators, and I end up like that. This is exactly the same. So my lowest common denominator, as Tegofatso said, is sine 12 cos 12. So that means that I need to multiply this by cos 12. So I must multiply the top by cos 12 as well. So at the top here, I'm going to end up with sine 36 cos 12. And on this side over here, I've got to multiply that by sine 12. So I've got to multiply this by sine 12. So here I'm going to end up with minus cos 36 sine 12, like so. Now, at the top in the numerator matrix, what is that? What do we have in the numerator of this fraction?
A compound angle.
A compound angle, absolutely. So now we can see our compound angles are starting to show up again. All right, so Zandile, what am I going to do with this compound angle? How am I going to write what I have in my numerator? I'm going to write it as
Sine, open brackets, 12 plus 12, 36 minus 12.
good. Okay, because sine keeps its sign. Okay, so sine 36 minus 12. So Zandile has done the reversal of the expansion. Very, very nice. And at the bottom, I've got sine 12 cos 12. All right. Now at the top again. All right. 36 minus 12 leaves me with
24.
24. So at the top, I've got the sine of 24. And at the bottom, I have sine 12 cos 12. And what do you notice about 12 and 24, Zandile?
24 is double 12.
Exactly. So now we are using double angles. Exactly. So how would you write the numerator?
12, sine 2 open brackets 12.
Lovely, over sine 12 cos 12. Good job. All right, and then what would we do?
Then it will be 2 sine 12 cos 12 over sine 12 cos 12.
That's it. So then we would end up with 2 sine 12 cos 12 over sine 12 cos 12. And now I can do what?
They can cancel each other out and be left with 2.
There you go. So I would cancel those out because anything divided by itself is 1. And as she says, my final answer would be 2, which someone popped in the chat. So you are 100% correct. Yes, Big V, that is quite right. Thank you, Zandile. Very well done. Okay, how does everybody else feel? Does this make sense?
Ma'am, I have a question.
Sure, so go for it.
So, ma'am, can you please explain how the 2 came to the front of sin 12, like that whole process there?
Okay, so what Zandile was doing is she was expanding this using her sine double angle identity. Okay, so the sine of 24 is 2 sine 12 cos 12 according to our identity. It is
Yes.
our double angle identity. All right, so this is what she was using over here. All right, so sine 2a, that was the 24, and she wrote it as 2 sine 12 cos 12. That was the identity. Okay.
Okay,
All
thank
right.
you.
No problem. Let's see who else has got a hand up. Charity, your hand's in the air. Go for it. What's up, Charity?
Ma'am, sorry, I forgot to lower my hand. I'm sorry.
That's all right. No worries. Okay, cool. Kamachelo, do you have a question?
Ma'am, my question is, you see, sometimes they say evaluate without the use of a calculator.
Mm-hmm.
How do you notice when you're at the marking center that one has used a calculator?
Okay, so the thing is that you could put that into your calculator and you'd get an answer. All right, but all this working would be missing. All right, so all you'd have is the 2. All right,
Okay.
so you wouldn't have any of this. So what would they be looking for? Well, first of all, they'd be looking for a lowest common denominator. All right. They'd also be looking that your numerator was correct, okay, and that you recognized that that was a sine compound angle, okay? So there would be an accuracy here on the sine 24 because you've recognized that that was a sine compound angle and you've applied that identity. Then the next thing that they would be looking for is that you expanded sine 24 and you wrote it as 2 sine 12 cos 12. So they'd want to see that step as well, and then your final answer. So if the question said evaluate without the use of a calculator and you just wrote 2, you'd probably get no marks for it at all.
Oh, all right, ma'am. And then
Okay.
if it happens that, let's say, you wrote till, let's say sine into 2. No, go down. Sorry.
Sorry, that's okay. So that step
2.
there.
Yes, this step over
Yes.
here, and you wrote to that part, and then you wrote your 2. You're gonna get penalized the 1 mark or the 2 marks.
Yes, you would be penalized 1 mark. So the idea is that if you use an identity or a reduction formula, you have to write the expansion of that, okay, or write what you get when you reduced. So yes, absolutely. What I could do is I could actually leave out this step over here that I'm drawing the purple circle around. That I could leave out, but I would have to write that sine 24 became 2 sine 12 cos 12. That I cannot leave out.
All right, thank you, ma'am.
Okay, no problem. And then I saw Katleho's hand was up as well. Yes, Katleho.
Hi, ma'am.
Hi, Katleho.
Ma'am, I just wanted to know. Ma'am, I just wanted to know, is there another way of doing this? This question
No,
from the
Katleho.
second step, ma'am.
No, Katlego, I don't think that there is another way for you to be able to do this question. You would have to find the lowest common denominator, and yeah, I don't think so. I mean, often there are more than one way to do something, but with this one, I don't think so.
And with more practice, Katlego, you'll definitely
ma'am.
get it.
No, not from the first step, not from like where you change it, where you wrote it with like green and blue. But I just want to know that then the step after it, could it be different?
I don't think so. You mean where I've got the pink writing?
Yes, ma'am.
I'm just trying to think. Well, do you know what you could potentially do is, and I mean here you're sort of starting to get a little bit creative here, but if you've got sine 24 at the top and at the bottom you've got sine 12 cos 12, what you could do is you could put a 2 here and then you could times that by a half if you wanted to. All right, and then what that would give you is sine 24, and then here you would have half sine 24. You could do that, and then you could cancel that, and then you could say 1 divided by a half would end up giving you 2 as an answer. You could do that if you wanted. That would be another way to do it from the pink down. Don't know if that helps.
Also, ma'am. Yeah, ma'am, it does. Ma'am, can you also please explain the green and blue step? I'm kind of lost, ma'am. I really can't
Okay,
discern
so
this one. No, not ma'am. Sorry, not that one, ma'am. The one under it. Ma'am, I just want to understand what you did there, ma'am, because I really don't remember the whole compound angles thing, ma'am. I really
okay, so you
have not yet.
Okay, so you mean when I went from sine 36 cos 12 minus cos 36 sine 12 to sine 36 minus 12, is that what you say you don't understand?
Yes.
Okay, all right. So if you have a compound angle sine A minus B, that expands to sine A cos B. Sine keeps its sign, so it's going to be a minus. Then it would be cos A sine B. Okay, so that is your sine compound angle. So you would need to look at that numerator and recognize that that's what it is. All right, again, what you've got is the expansion. You've got the right-hand side, and what you want to do is this, sine A minus B. So that's what this step is. This step over here is going sine A minus B. All right, your compound angle formulae will be on the sheet. Right, but you need to be able to recognize them. So you've got to do enough practice with trig that you recognize all 4 compound angles, and that you recognize your sine double angle and your cosine double angle. So it's lots and lots and lots of studying. Okay. And then from there, once you said A minus B, 36 minus 12 gives us 24, then you'd know that 24 was double 12, and then you could proceed from that point onwards. Okay. All right, so let's go back and have a look at question number 1.
Ma'am, thank you, ma'am.
No
Sorry, ma'am,
problem,
I forgot
Katlego.
to respond.
No, it's fine, no stress at all. Okay, let's go back and have a look at question number 1. Is someone calling me?
Yes, ma'am.
Oh, sorry, Kagiso. Yes, did you have a question?
And the concept of cross multiplication, ma'am, when does that occur? Does that only occur with fractions when there's a multiplication sign?
No, Kagiso. Okay, so you're not alone. A lot of students get confused with cross multiplication, and personally, I blame it on primary school teachers. Whether that's fair of me to do so or not, I don't know. But in primary school, they do you a massive disservice because they show you how to cross multiply in order to get a lowest common denominator. So let's say here I've got 3/5. So they teach you this, I hate it, but they teach you this butterfly method where you're cross multiplying those numbers together like that. Okay. And in my opinion, this is what creates all the confusion. All right. Cross multiplication is a method that's used to solve an equation. It's not a method that's used when we're working with fractions. So if we're working with fractions, let's say I've now got 1/2 times 3/5. I'm not cross multiplying. I'm multiplying numerator with numerator and denominator with denominator. When you cross multiply is under a situation like this. Let's say you have x/2 equals 3/10 for argument's sake. Now you're going to cross multiply. So you're going to multiply the 10 over here with the x, and you're going to end up with 10x. Then you're going to multiply the 2 and the 3 together, and you're going to end up with a 6, like so. Okay, so cross multiplying is a method to solve an equation. It's not a method for working with fractions. Okay, the reason that it works when we're solving equations is because cross multiplying is the same as multiplying both sides by 2 and then both sides by 10. Okay, so if I multiply both sides by 2 and both sides by 10, I would get the same effect as cross multiplying. Okay. Does that answer your question? Cool. Sorry if I offended anybody's primary school teacher, but that's where I think it comes from. Okay. All right, let's go back to question number 1. So in the numerator, we have sine 35, cos 35. They're both acute angles, and we can't really do anything with that. So we're going to leave them alone. Looking in the denominator, we've got tan 225, cos 200. If you have got angles bigger than 90, use grade 11 reduction formulae, okay? Go with 180 minus 180 plus 360 minus first, and then only use co-functions if we're working with sine theta and cos theta. Okay, so obviously we're not going to use 90 minus and 90 plus for 225 or cos 200. And again, if you used co-functions, it would either it would have to be something that was either in the second quadrant or in the first quadrant, right? Okay, so tan 225 is 180 plus 45. So this would reduce to tan 45. Cos 200 is in quadrant number 3. Okay, so it would be 180 plus 20. Cos is negative in the third quadrant, so this would reduce to negative cos 20. Okay, that's the easy bit, right? We have a special angle involved here. We've got tan 45, which we know is 1. So we're going to write all of this as sine 35, cos 35. And if we multiply something by 1, it doesn't change, but I'm just going to put the 1 there anyway. Okay, so now we get to this point over here. Any ideas on how we should proceed at this point? Is there a relationship between 35 and 20? So now we've got to try and find a relationship between these two, either using reduction formulae or compound angles or double angles, something that we've got to do first. Any ideas? Sinan Corsi, go for it, Sinan Corsi. What would you do?
Ma'am, I said I changed sine 35 cos 35 to 1/2 sine 35 cos 35, which then gave me 1/2 sine 35 plus 35.
Okay.
Oh.
Okay, so in other words, what you did here is you put a 2 here, you times it
Yes.
by a half. There's nothing wrong with that. And then that gave you half sine
35 plus 35.
Okay, which would have given you sine 70, right?
Yes.
Okay, all right, that's fine. Over.
1 times negative cos
Yes.
70, 90 minus 20.
Okay, right. Okay, so then here you said 90 minus 20. Okay.
And then I had 1 over 2 sine 70 all over
Hold on.
negative sine 70.
So hold on, 20 is 90 minus 70, sorry. Okay, and then you had 1 over 2 sine 70 over, keep going.
All over negative sine 70.
That was, yes.
And then the sine 70 and sine 70 cancel each other out.
Sure.
Leaving me with a negative 1 over 2.
Perfect. All right, well done. Okay, absolutely. That's one way that you could do that question. There is another way that we can do this one as well. Perfect. Well done. Minentle, do you want to ask a question?
Evening, ma'am.
Good evening.
Ma'am, may you please repeat the part in blue?
Okay, all right.
How is it? Yes.
All right. So, what has happened here? Yes.
I'm sorry, ma'am, to disturb, ma'am. Can you start from where you multiply with a half and a 2, ma'am? Can you please just explain where the 2 is coming from?
All right, that's fine. Let me do that again for you guys. Not a problem. Okay. There is another way that we can answer this question, but it's absolutely not a problem that we we do it this way. All right. When you are in a situation where you have sine A cos A, the coefficient of sine A cos A is 1. You can manipulate that though, because you can write 1 as 2 times a half. Okay, so that's the trick to this, right? Is writing 1 as 2 times a half. So what we are doing here is we've got our half times 2, which is 1, sine 35 cos 35. Because this over here is our sine double angle. Okay, that's the idea. Right, so that's quite a common thing that comes up actually. If you've got sine theta, cos theta, is that you can put a 2 in front of it and times it by half, and then you've still got your coefficient of 1. Does that make sense to everybody?
Ma'am?
Yes.
What if I just write 2 over 2, like the whole sum, like sin 35 times cos 35, 10 whatever, times 2 over 2?
Okay, but then are you going to remember that you've got half sine 70? Are you going to remember that?
No, actually.
Yeah, so rather write it as half times 2 than 2 over 2. Okay, because that'll help you to remember that it's now going to be half of whatever your double angle is.
Oh, okay.
Okay, all right, no problem. All right, so now let's keep going. Then at the bottom, we've got negative cos 20. So in our next step, we're going to apply our double angle formula, and we're going to end up with 1/2 sine 70. Okay, and then what we are doing over here is we are saying that the cos of 20 is the same as the sine of 70. Because remember, cos and sine are co-functions. Cos theta and sine theta are co-functions. So if the angles add up to 90, we know that they are equal to one another. So for example, if you have the cos of 2 degrees, you know that that's equal to the sine of 88. Okay, they are co-functions. Right. So you actually don't have to show the reduction formula. You can go straight to writing minus cos 20 as minus sine 70, just like that. Okay, and then you're going to say sine 70 divided by sine 70 is 1, and a half divided by negative 1 is going to leave us with minus 1/2. Okay, so the other way that you could have done this, not that it's vastly different from this solution over here, is at this step over here, okay, instead of multiplying by 2 and then by a half, what you could do is you could leave it as sine 35 cos 35 at the top. And then at the bottom, you can write the cos of 20 as negative sine 70. And then you know that 70 is double 35. So you can leave sine 35 cos 35 in the numerator. And at the bottom, you can write minus 2 sine 35 cos 35. So you're using your double angle and you're expanding. And then you can divide something at the top with something at the bottom, something at the top, the same thing at the bottom, and you're going to end up with the same answer, which would be negative 1/2. All right, so that would be the other way that you could do it from that point. Yes, Tegofatso.
So ma'am, when we cancel, don't we cancel the whole term, or we cancel each, like sin 35, don't we cancel sin 35 times cos 35 as a whole term?
You can do that. You can say sine 35 cos 35 divided by sine 35 cos 35, absolutely. Or you can split it down, it doesn't matter. The idea is I'm not cancelling over plus and minus. I'm cancelling factors, I'm not cancelling terms.
Yeah, because I was told that if I cancel each term like the way you did, I'll get penalized.
No, you won't. I don't know who told you that, but no. No. I mean, because the thing is those are not terms, those are factors. That entire thing in pink is one term.
Yes, I see.
Okay, so it would be exactly the same thing if you said sine 35 cos 35 and then here's sine 35 cos 35. It's exactly the same thing, I promise.
Okay, thank you.
Okay, no problem. No problem.
I'm not sure if Minentle has a question.
Okay,
The hand
Minentle, do
is
you
up.
have a question? Sure, Minentle, go for
No,
it.
no, I don't have a question.
Okay. All right. How are you feeling, Matrix? Is this making sense? Are you happy? Thumbs up, thumbs down? How do we feel? Oh, good. Oh, good. It's so nice to see the thumbs ups. You sure? Okay. All right. Okay. Well, that's good, Yolanda. They've all got thumbs ups. No one's put a thumbs down so far. Good. Well done, everybody.
Loved it and everyone understood it, and I'm happy also.
Good. Me too.
Can we run the poll or not yet?
Just give me 1 second. Okay.
Okay, perfect.
When do we know that we are left with 1 after cancelling? Because anything goes into itself once. So that's the idea behind cancelling. Or, I mean, unless, of course, you're cancelling, you know, things where you've got a highest common factor. But I mean, in this case over here, sine 35 goes into sine 35 once, as does cos 35 into cos 35. Okay, so that's how you would know that there's a 1. No, Lesedi, don't do that. Okay, even though 270 minus does work, it's not part of the CAP syllabus. So don't use 270 plus or 270 minus. They are reduction formulae back in the day when we did higher grade maths and standard grade maths, we use 270 plus and 270 minus, but it's not part of the syllabus. So only use 360 minus, 180 plus, 180 minus, and then your co-functions. Okay, so yeah, stay away from that. Because it's actually also a co-function. The cos of 270 minus would end up being the sine of something. Can they mark you down? Yes. Yes, they wouldn't want you to do that. Okay, yeah, so stay away from that. All right, so almost ready to run the poll. What I wanted to do here is there are a lot of questions here, which unfortunately we haven't had a chance to practice in class. What I would like to suggest, if I may, is try and do some of these for homework. So I would suggest you try question C is a nice question to do. Question F is a nice one to do. Question H is a nice one to do. And then I would also try question I. That would be a little bit more difficult. Okay, so I'm going to set that as homework for the next time. Of course, if you don't do it, there's no punishment, but obviously it's on you whether you want to do this or not. And obviously I'll provide the answers next time as well.
So ma'am, you only put the answers next time. So like, let's say
yes,
I want to mark my work now to see where I went wrong. Isn't there a
yeah.
way I can the memo?
I haven't got the answers to hand at the moment. I would need to work these out first.
Yes.
I can tell you quickly what the answer is, what you would be expecting, but
Yeah.
I don't have the memo yet, no.
Okay, it's cool then.
Okay, sorry, Tegofatso.
Okay.
Okay. All right, so somebody wants to take screenshots. Okay, you want me to go all the way up to the top? Okay, Ludwina, am I in the right place here?
Is it now time for me to run the poll?
Yes, go for it, run the poll. Thank you, sorry.
No, that's fine. Let's vote my people. Y'all did really well today. Let's go. Okay, no, my background is gonna be so noisy, Teacher Lee, but I can see them voting, so I'm just gonna mute myself so long.
That's fine, no problem.
In case if they have questions.
Okay, Ludwina, I'm just gonna go down so you can screenshot here as well.
Ma'am?
Yes, Tegofatso.
Between Trig and Euclidean, which one would count the most marks and which one would be like the one we should spend time doing most in the exam?
Okay.
Like paper 2.
Focus on Trig before you focus on Euclidean geometry.
Yes.
Trig is not worth as many marks, but there's not a big difference. Trig is about 40 marks. Euclidean geometry is typically about 50. Although in sort of the last year, I don't know if it was because of COVID and whatever, they kind of reduced that a little bit. But your paper 2, the first couple of questions are going to be on statistics. The next questions are going to be on analytical geometry, and then Trig is the next section. So in my opinion, you should try and do as much Trig as you possibly can. The Euclidean geometry is typically seen as the most challenging. So really what you want to be able to do is access as much of the Trig as you possibly can and then go on to Euclidean geometry. So that would be my...
Yes, because I usually, in the past, I usually do Euclidean. Like I wouldn't have the energy after doing the rest of the stuff to do Euclidean at all. So I just skip every single question.
Yes, yeah, absolutely. And hopefully by the time we've done lots of revision practice, you'll have the confidence to at least try some of the Euclidean questions. But they are typically your difficult problem solving, higher order thinking. So yeah, spend time with Trig.
Okay.
Okay.
So how would you advise me to study like time management wise? Like let's say I have a whole paper here set for me, like a paper 2 paper, and I have a so should I like time myself?
You
in terms
should.
of
You
doing the work,
yeah,
or
absolutely. No, absolutely. You really should. So maybe what you should do is do it like question by question. So if you've got a question
Yes.
in front of you, net sets out of 20 marks, then
Yes.
you should say to yourself, okay, I'm going to times 20 by 1.2, and that's the number of minutes I'm going to set myself. And then put an alarm on your phone and put the phone down on the side and then start working. And then you'll be able to see whether your timer goes off, whether you are finished or not. So take the marks and times it by 1.2, and that's how much time you should be spending on it and no more.
So if I take a little bit longer, let's say I'm studying at home now, obviously I'm not obliged to like be on that time, like be present all
No,
the time.
absolutely. And the thing is that the more you train yourself to do this, the
Yes.
easier it will become for you as well. And I mean, that's a strategy that I used at university when I was studying for my exams. I trained myself to be able to finish questions and do calculations within a certain period of time. And it really, really helped me when I was writing my exam. So yeah, I'm a big advocate of that.
Okay, thank you, ma'am.
Okay, all right.